Winter returns, but for how long? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 24th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell, you get automatic notifications when the videos are posted, typically on Sunday evenings. To subscribe, just click the Stormsurf icon down in the lower right-hand corner of the screen. And if you'd like to make a contribution to the cause, you may. Just select the heart with the $sign in it down below, and you can make a small donation. With that, I'd like to thank the folks that donated last week, and they're all longtime contributors. Our Predicament, Tim Caston, Evolution Moto, Kim in California, and Elliot Harris. Thank you so much for your donation. And with that, let's get to work. We'll start by looking at significant wave heights for the North Pacific Ocean. We see remnants of a gale here with 22-foot seas in the northwestern Gulf of Alaska, not doing a whole lot. And we also see some seas, locally generated seas, produced by northwest winds pushing down the California coast. But all in all, a pretty placid pattern for the moment. Let's make a quick look at current conditions. We'll start in Northern California. Point Reyes Buoy off of Point Reyes, California, Northern California. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period, really long period energy, the whole way down to 5 second period, just pure wind chop. These numbers here are the height of the swell energy in each period band in feet. So 0.8 of a foot at 18.2 seconds. You get the sense here there is some very small long period energy underneath, but the bulk of the energy appears to be wind swell somewhere in the, we see 4.3 feet at 11 seconds there, and another bit of energy in about the 9.5 second range. But not, the swell is not identified by a single period. It is the energy on both sides of the shoulders of the main period that defines a swell's height. You aggregate all these heights together to get what the true swell height is. Takes a bit of some tricky math. Anyway, looking at that, we see primary swell 9.2 feet at 10.4 seconds from 294 degrees. Theoretically, that's surf at about 9.5 feet. And yeah, it's pretty big, but it's also a blown out mess. And then there's really no secondary swell. Significant wave height. Now, this is a good bit of info here. Significant wave height is the aggregation of everything hitting the buoy, but you can't be riding a 0.8 at 18 second period swell along with 4 or 5 feet of, wind chop on top of it. So this is really for boaters, and it just sort of gives you a sense of how big are the highest 1/3 of the rogue open ocean waves that you'll hit if you're out there trying to fish or whatever. 12.1 feet at 11.1 seconds. And there's also a chop height factor here. That's for energy in the 2 to 5 second period range at 3.5 feet. So you get a sense it's pretty much a blown out mess. Then we go down to Southern California. The Point Loma South Buoy is off of San Diego, buoy number 191. You see the same sort of profile, but smaller because, of course, the Channel Islands block a lot of the wind and the wind swell and even the pure swell. But you see a little bump here at 13 seconds and a much larger bump in the 8 second period range. Primary swell, 7.8 feet at 7.9 seconds from the west, 277 degrees. Theoretically, that's surf at 6 foot. Don't know if that's really how big it is, but at least it gives you a rough idea. And then significant wave height, 10 at 7.7. Again, just pretty much a mess. And this chop height, when you see chop heights of like 1 foot, that's good. 2 feet, it's getting pretty marginal. When you get into the 3 foot range, it's pretty much a blown out mess. And then we go down, or actually over to Hawaii, North Shore of Oahu, Waimea Bay Buoy number 106. We see some new energy trying to pop in there at about 20 seconds. There's been a series of gales that have pushed off Japan, made it to the date line, but that's about it. This is likely one of those swells, and you even see some additional energy out here in the 22 second period range. Then you see what is likely lingering energy from a previous gale off Japan, and yet wind wind swell, the typical east trade sort of thing going on. Putting that all together, primary swell 1.8 feet at 20.4 seconds from 309 degrees, and that would make surf in the 3.7 foot range. I mean, there are waves. It looks like it's classic fun late season Hawaii in the shoulder high range, and basically beautiful. A big difference from California with secondary swell 2.6 feet at 13.9 seconds, and chop height 2 feet. So not too bad, but you got the easterly trades, right? And that's wrapping into the buoy. So not a bad situation. All right, so let's visualize where these swells are coming from. Here we are, North Pacific Ocean, California here, Gulf of Alaska, Aleutian Islands, Japan off here, Kuril Islands, Kamchatka. Gale, we're going back to Tuesday, March 19th, so about 5 days ago. A gale pushed off of North Japan with 26-foot seas right there, maybe 27.5 feet. The highest seas over this entire domain at 41.5 north, 157.5 east. Well, there's 157.5 east there, so it lines up pretty good. This is what is generating or has generated some swell pushing into the Hawaiian Islands. And you notice the date line right here. This gale didn't even make it to the date line on Thursday. Then here comes another system. Anyway, I'm sorry, that is the swell. You can see the swell front there that is pushing into the Hawaiian Islands here on Sunday, with an additional gale that developed on Thursday off Japan. Now, this one a little bit more energetic with 38-foot seas, and that 36 fading from there, making better progress, though, off to the east-northeast, crossing the date line on Saturday, the 23rd of March, and then let's see, we're approaching today, moving into the northwestern Gulf of Alaska, and that is the gale that is fading up there now. Swell from it, you can almost see the swell front here. And actually, some of that energy might also be embedded, starting to hit the Hawaiian Islands too, but it looks like the bulk of that is all going to arrive on Monday. We'll see that when we get to the forecast section. Then we go down to the southern hemi. Yes, believe it or not, we're actually looking there. It's on Wednesday, the 20th, so just 3 or 4 days ago. Little gale pushed under New Zealand, 29-foot seas, 29.9-foot seas, building to 32 feet. But notice it's sort of falling. We'll just put this back in motion here. Sort of falling east-southeast, so not really pushing energy up to the northeast, sort of more aiming the swell main swell propagation path into, we'll say, Central and South America. That system pretty much faded out as we got into Thursday. But there's another little system that blew up sort of unexpectedly Friday evening. This would be Friday the 22nd of March, and right here, actually, we'll go back one more frame right there. Yes, 30-foot seas, and this system well to the north. Swell from it radiating north towards California, probably going to arrive in about a week, maybe even a little bit less, and probably just focus mainly on Southern California, but certainly into Central America and Peru as well. And this system quickly faded out as we got into Saturday. And we'll just roll this out into the current time, and you see nothing else behind that. All right, so let's go forward, and we'll go forward 180 hours, 1 week. Why only a week? I mean, the models go out 2 weeks. Yes, they do. But honestly, even a week out, they're not very reliable. For the GFS model, about 4 or 5 days out, you have a pretty good handle of what's going on. And typically, the models do more or less what they're forecast to do 4 or 5 days out. But more than that, it's just pretty much a fool's errand to try to, really believe anything. And you go out 2 weeks, you're in dreamland. Just forget it. All right. So anyway, on Sunday, that is today, we are looking at Jetstream level winds. These are winds up at about 30,000 feet that help support the formation of gales. And when those gales form, the jet stream helps direct their track. We're looking for a trough, a dip in the jet, just like we see right there. What that helps do, and you can see a little low pressure system there. This is in the upper atmosphere. That creates a counterclockwise flow aloft and down at the ocean surface. And of course, low pressure is what generates wind. Wind, if it's strong enough, gets traction or imparts energy to the ocean surface, creating seas. Seas, as they radiate away from the fetch area, well, the shorter period elements, because they don't have a lot of energy, they die off. exposing the longer period swell. And of course, swell when it hits your beach, like Hawaii there, California there, then you get surf. And swell is the best. I mean, wind swell is okay. Wind swell, I'd say pretty much 13 or 12 seconds or less in California, Pacific Ocean. On the East Coast, I would say 10 seconds is swell, and anything less than that's wind swell. Some people might say even 9 seconds. So take your pick. Anyway, what we have is a good consolidated jet stream pushing the whole way across the Pacific with winds at 150 knots pretty much in this whole flow right here. One trough there. You also see another trough here pushing into California. It also created some weather and some rain and that sort of thing. If you're in the California area, you know what I mean. This is a pretty good flow. We'll see how this plays out, though, over time. And that speaks to the title of the video. We'll get into that in a minute. So consolidated flow, jet pushing into California as we get into Monday. The trough over the date line starts moving towards the Western Gulf and into the Central Gulf on Tuesday. So still supporting gale development. Another trough tries to blow up here off of North Japan. As we get into Wednesday, nice trough here. Aiming at California, still have a consolidated flow, but look, there's a little bit of a split trying to develop here, even west of the date line as we get into Wednesday. As we're into Thursday, here we go, trough in the Eastern Gulf, a front, and almost like I wouldn't call it an atmospheric river event, but, the jet pushing into the Sierra, and another trough here, of course, off Japan, both supporting gale development. So we get into Friday. Now, look at this. You have this giant split right here, the jet ridging north with a lot of energy. When you get the split jet stream flow, that typically means high pressure. So you have low pressure here, high pressure here, a bunch of winds, but as soon as the jet starts pushing onshore, it'll probably be a northwest wind event for California. This trough here, so again, Friday starts pinching off, and look at this, by Saturday, full-on backdoor trough scenario. The jet pretty much split from the date line and points east of there. There's a reason for that. We'll get into that in just a minute. And we're into Saturday and even Sunday. The cutoff trough or backdoor trough, whatever you want to call it, still persisting. This is really typical of the inactive phase of the MJO, and we'll get into that in a minute. We'll have a great example here. But anyway, last trough in the northwestern Gulf, fading out. The backdoor trough trying to push into California a week from now. And the jet fully split. Looks like it's splitting even back here to west of the date line. All right, so let's go to where we are right now. Basically, fully consolidated jet, active phase of the MJO, and we get into that discussion, but those of you that watch the videos know. Active phase of the MJO feeds energy to the jet, consolidates the jet, and helps support gale development, and also pushes the jet into California. And then you get into the inactive phase, the jet splits, you get this whole sort of thing. But what the inactive phase does do relative to California, if the jet splits far enough back here, it kind of does this meandering thing up towards the Bering Sea and then crashes down the Pacific Northwest coast, making backdoor troughs. They don't bring copious amounts of moisture, but what they do is drag cold air down with them. So whatever moisture you get does great for snow production in the Sierra. We could certainly use it. We're not in bad shape. I think we're about 100% of normal right now, but we for this time of the year, but we still need more to eke out a normal kind of pattern for the entire season. This looks good. So then I did cheat. I went and looked at the 2-week model just to see what's going on, and this pattern is to persist. This very split jet stream pattern, backdoor trough sort of scenario for the next 2 weeks. Do I believe it? No, but the one thing I do kind of go with is, well, if the MJO is going into the inactive phase, which, if you watch the video, it probably is, then it might be believable that we have still a couple of weeks of snow coming our way. Good news. All right, but from a surf perspective, the jet stream is not blowing or imparting energy to the ocean surface. It has to manifest itself down on the surface in the form of low pressure, creating wind. So here we are right now. Here's the northwest winds pushing down the California coast. We know the jet is kind of meandering around up here. Here is high pressure, creating trades over the Hawaiian Islands, and the last remnants of a gale that was previously off Japan, fading in the northern Gulf with 30-knot winds. We'll put this into motion. As we go into Monday, the northwest wind pattern starts fading for California. Trades for the Hawaiian Islands. We're not going to get into that yet. We're looking for gales. And here we go. As we get into Tuesday night, gale starts building off of the Pacific Northwest with 40-knot winds, another gale off Japan with about 40, maybe 45-knot winds. This gale lifting fast to the north. If you remember the jet stream flow, it was almost kind of pinched and lifting north. But the system off the Pacific Northwest, good fetch of 40-knot winds aimed at California and continuing to circulate through Wednesday. Now here we are, Thursday. The gale, like in 2 days, goes from off Japan to basically in the Bering Sea, while this gale off of the Pacific Northwest continues to linger. And if anything, we saw the backdoor trough getting organized. Sure enough, here's low pressure building in that trough, lingering off the California coast, and if anything, targeting Southern California and Baja. Not great winds, maybe 30-knot winds, but probably not too bad for producing some late season weather. And here we are, a week out, continuing to circulate off of Southern California. We have some sort of nondescript low-pressure system here, and was that not the sea, maybe the China Sea? I'm not sure what's hiding back there, and a little bit of low pressure up here into Alaska. But from a surf perspective, this one off of California is probably the main deal. What are the effect of those winds on the ocean surface? Well, we know we have remnant energy producing 22-foot seas. That's good for maybe some 13-second period swell. But we know, just looking at the buoys in Hawaii, there's some 20-second period energy starting to arrive there. Let's get ourselves into Monday. Really, nothing happens. Tuesday, nothing yet. Wednesday is when the action starts. Here we go. 28-foot seas here in the Gulf of Alaska, targeting California. Another area of 26-foot seas approaching the date line. As we get into Thursday, this system moderates some 23-foot seas and 28-foot seas over the northern dateline region. Through Thursday, then things settle down, but we know this system is going to try to redevelop off California. Is it really a swell producer? Well, what is that, like 17-foot seas? Maybe. Actually, that shorter period, if 17-foot seas would produce a shorter period swell, but that would maybe work its way through the Channel Islands and the shallow waters better than longer period energy, which reaches further down toward the ocean, or down into the depths of the ocean, creating drag and decay. And even here we are, Sunday, little gale forecast up here, 32, 33-foot seas and 18-foot seas off of Southern California, and then things settle down. And then we go to the Southern Hemi. So we know that there is a gale, actually two gales that have produced swell pushing north, and there's actually been at least two others prior to that. Why was that? It's kind of early in the year. Well, of course, the active phase of the MJO has been traversing the Pacific, right? When the active phase is in the Pacific, especially in the West Pacific here, it feeds energy up into the jet stream. It's effectively a low-pressure system. It takes warm, moist air down at the ocean surface, lifts it aloft. That gets caught by the jet stream, and that warm, moist air energizes the jet stream, causing it to consolidate. And that, in turn, affects both the north and the southern hemi. So we've been in a pretty good sweet spot for storm development. But we also know that the jet stream is looking to split in the northern hemisphere. And if I were to pull up the southern hemi jet stream chart, you'd probably see it doesn't look particularly well as we go into the future. In fact, you can just see the storm track falling southeast, symptomatic of a split jet stream in the southern hemi. And so just like the northern hemi, it doesn't do much for swell production. Yes, we have 32-foot seas. They're all falling south, targeting Antarctica. Penguin storm doesn't do really anything for us. Now, we do get into this sort of pattern as we get into Saturday, the 30th of March, where we get a series of gales producing 26-foot seas running pretty much due east to west, west to east, I'm sorry. That might be good for Chile and maybe up into Peru, but even at that, we'll see. Not anything really obvious for Hawaii, California. Typically want to see at least 32-foot seas, preferably 40-foot, but 32-foot seas, typically over a pretty good area, produce a long enough period swell to survive the trip across the equator up to the north and not decay too much. Next up, wind forecast for California, right here. Hawaii, down there. High pressure, the name of the game for the moment. Winds circulate clockwise around high pressure, and we have a bit of a gradient with low pressure, that low pressure trough moving inland, creating northwest winds at 20-25 knots. It's a blown out mess, and up here in San Francisco and pretty much all down the coast, even down into Southern California. Hawaii under the influence of strong trades. We'll go into Monday the 25th of March. Northwest winds settle down some relative to California. Still brisk. Trade's pretty brisk for the Hawaiian Islands. Tuesday, as we get maybe later in the day, low pressure starts building, cuts out the legs of the high pressure. Northwest winds start fading along the California coast. Trades also fade for the Hawaiian Islands. So we get into Wednesday. Now here comes the next front. South winds down to San Francisco in the morning. Light trades for the Hawaiian Islands. You see the south wind pattern almost making it down to Point Conception later on Wednesday. Thursday, the low continues to circulate off the coast. You get the drill. This is going to be like the standard steady south wind event. Trades, 20 knots for the Hawaiian Islands. As we get into Friday, here's your south winds, not particularly strong because the low's not super well organized, and maybe even working towards offshore winds as we get up into, we'll say, Oregon, but not North California yet. Trades moderate for the Hawaiian Islands. Saturday, here's our new low, pumping south winds up into Central California and Southern California. An offshore flow. Remember, low pressure circulates counterclockwise, so the north quadrant of the low with offshore winds, so for Northern California. Light trades for the Hawaiian Islands. So we get into Sunday, pretty much the same deal, no change. And that's what it is. Let's take a quick look at precipitation. Here we are, Sunday afternoon, evening. California here, the San Francisco Bay Area right there. You see rain. It's not steady rain. It's showers. I mean, some of these showers are actually pretty intense, putting down a good amount of water, but only for a short period of time. Still steady snow in the Sierra. We'll move forward here into Monday. Things dry out for California. Things continue dry on Tuesday. We know there's another low winding up off the coast. The front hits Cape Mendocino midday Wednesday, works its way down to San Francisco Wednesday afternoon, and the snows start maybe late afternoon for the Lake Tahoe area. Push their way south into Thursday morning. Pretty good amount of snow, but short-lived. The system sort of backs off some, but more rain for Northern California, and then trying to work its way down the coast. Now notice this, the low more focused off the coast as the trough becomes more super backdoor focused. Eventually it will push in. Oh, and actually, let's go back right there. Here we are. Friday night, see some snow there in the Sierra, but then it looks like it almost turns to rain. And then here comes the next push. This focus on Southern California and Central California with snow for the Central Sierras for Saturday during the day. But also it looks like it turns to rain. So hard to tell exactly how this is going to play out. Again, we're out almost a week, but definitely some precip for California. Here's the snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. A couple of inches of snow, but then as we get into the 28th, I believe that's the night of Wednesday, the morning of Thursday, another dump of snow forecast with about 30 inches, and then lingering additional snow getting you to 3 feet, maybe even a little bit more to 3.5 feet, and then theoretically another dump out by April 4th getting you to 48 inches. Let's go look at some other resorts. Kirkwood pretty much on the same program, getting to about 42 inches of snow over the 10-day forecast window. And Mammoth actually doing better with these latest runs than previous runs with 36 inches forecast. And then looking at the freeze level, this is for Palisades, Tahoe. This is the base of Palisades at 6,200 feet, the summit at 9,000 feet, up at the top of Granite Chief and the Palisades themselves proper. Blue is 28-degree temperatures or less. White is 28 to 32. The gray is sleet at 32 to about 35 degrees. And everything that's red, no matter how much precipitation comes down, it'll be liquid precipitation. You can see today the freeze level right around 5,000 feet. Forecast to slide up as we get into the 26th and the 27th. That's Monday and Tuesday. Then Wednesday, it starts falling and down to, again, 5,000 feet, if not dropping to 4,000 feet. And that's all good till you get to about the 30th. And then you see the freeze level going well above the base at, we'll say, 7,000 feet up to 8,000 feet. Actually, this isn't as bad as what previous runs of the model. They had it up at 10,000 feet a couple, out towards the end of the model. So, subject to change out here, but for sure for right now, still a pretty good pattern for producing snow. Surf forecast for Ocean Beach, Northern California, 2-foot surf. That seems a little low given where we're at. But it's probably a function of wind swell more than anything. Anyway, surf coming up into the 9-foot range. So we get into Wednesday with that low off the coast. And Thursday up to maybe 13 or 14 foot and then heading down from there. Looking at the winds, we see just a blown out mess here of northwest winds, 20 plus knots, finally settling down as we get into maybe Thursday. Maybe there's a little bit of hope there. And then the winds come back up. Not horrible, but not great. Swell heights, 1 foot at 17 seconds, something like that. 3 feet at 13 seconds. The big push on Thursday, 10 feet at 13 to 14 seconds. We go down to San Diego, 7-foot surf on Monday morning. That's suspect. I bet you a lot of that's just wind swell. And you see this one does this big jumpy thing. That typically is real swell, pure wind chop, all mixed together. Not great. Anyway, swell fading down. But then as we get into Thursday, Friday, into the 2 to 3 foot range sort of thing, and maybe up to 5 feet as we get later into next weekend. Then we go to Oahu, the combination of Japan swells coming together, producing 8.6-foot surf on Monday morning with basically no wind or light winds, then fading down, trade start building back in 20 knots, and surf heights in the 4-foot range and heading down from there. No big surprise seeing how the jets start splitting and really the storm pattern starts fading, at least from a swell production standpoint. Looking at swell heights, 5 feet at 16 seconds on Monday. That's good. And then working its way down 3.5 feet at 13 seconds. Maybe another little pulse as we get into Thursday at 3.5 feet at 11 to 12 seconds. And then down a little bit from there. All right, let's go take a look long-term. What's going on with the two major oscillations that affect long-term weather? The MJO, the Madden-Julian Oscillation, and, of course, the El Nino Southern Oscillation, ENSO. We'll start off talking about the MJO, the Madden-Julian Oscillation. As you know, there are two phases, the active phase and the inactive phase. The active phase is like a low-pressure system. That is good for storm production. The inactive phase, high pressure, not good for storm production. They rotate around the planet on opposite sides of the planet. The active phase on one side, the inactive phase on the other. They rotate on the equator from west to east. So that's sort of a pattern. It is the active phase when it moves over into the far reaches of the West Pacific that it takes warm, moist air at the ocean surface, lifts it aloft, that gets captured by the jet stream, both north and south, and that energizes the jet stream, helps create troughs, helps create storms. When the active phase when the active phase takes about 4 to 5 weeks to make its way across the Pacific, and then it's on its way. What follows right behind is the inactive phase. When the inactive phase comes, it's a high-pressure system. It basically cuts off the flow of warm, moist air aloft, and then the jet stream gets weaker and it splits, just like what you saw in the model's forecast a week from now. All right. Also, the active phase down at the ocean's surface, what it does is it reverses trade winds wherever it is on the equator. So we have data from the TAO buoy array here, a series of buoys used for monitoring El Nino, but the wind sensors on them can help us tell if the trade winds are reversed or weakening, giving us a potential clue as to whether the active phase of the MJO is in the Pacific. All right, so we start here. This is in the far East Pacific here. We're just looking, these are 5-day average winds. They're blowing moderately hard out of the east in the East Pacific, pretty strong hard over the Central Pacific, and moderately strong over the West Pacific. So no obvious sign there, but the anomalies, the difference from normal for this time of the year, that is the real clue. And we go into the East Pacific here, and we see kind of a neutral wind pattern. And then you get here into the Central Pacific, and you actually get hints of just the arrows coming out of the west a little bit. So maybe the active phase is somewhere around in here. Then you even get into the West Pacific, and it's completely neutral. So not the inactive phase in control, active phase somewhere here, but not particularly strong, at least looking at this bit of data. But we need more data. These are the zonal wind anomalies, the east-west component of the wind for the past 5 days. Let's get ourselves oriented here. South America, Central America, 0 is the equator, 180 is the dateline. Far West Pacific here, that's New Guinea right there. The Kelvin wave generation area right in here, that is the all-important area where when the active phase moves from the Indian Ocean over the maritime continent to the West Pacific. That's where it does its best thing in terms of injecting energy to the jet stream. So 5 days ago, or whenever, the 18th of March, west anomalies. Oh, the oranges are west anomalies, synonymous with the active phase of the MJO. Blues are easterly anomalies associated with the inactive phase. I'd go active phase in the Pacific, inactive in the Atlantic. Pretty much the same pattern on the 19th, the 20th, the 21st, and then the 22nd, but it looked like the balance of the westerly anomalies on the 22nd are moving south of California, suggesting the active phase is moving that direction as well. All right, so here's another chart that shows east and westerly anomalies, 850 millibar zonal wind anomalies. So this isn't at the surface. This is more up like about 4,700 feet, but a reasonable proxy for what's going on at the surface. Now, this is the whole planet. The date line right in the middle of the chart, we know that's in the Pacific. New Guinea's over here at 125 east, so right here. So this is the beginning of the West Pacific. California's at 120 west, and Ecuador is at 80 west, so right here. Kelvin wave generation area roughly right down the middle of the chart. You can see the blues, easterly anomalies. This is probably the inactive phase of the MJO, the end of February into the early part of March. Here came a weak active phase traversing the planet, starting in the Pacific, right around here, starting mid-March, and making it over the date line, and looks like it's east of the date line, maybe even south of California right now. And here comes what looks to be an inactive phase in a day or so, pretty much taking over. It's interesting, though, as we get, it's only like 1.5, maybe 2 weeks, and then westerly anomalies are forecast. We'll see if that really down there materializes. I don't believe it will, and I don't believe there's some sort of active phase showing up there. That might be some other form of tropical variability. Since the active phase of the MJO is like a low-pressure system, well, it also creates clouds. Warm, moist air lifted aloft condenses as it hits cold air in the upper atmosphere, creating clouds. This is a chart showing the tendency for there to be clouds or not clouds. Outgoing long-wave radiation, cloud cover. If you have more clouds, you can't get sunlight reflecting off the ocean surface, and that would be the blues, negative anomalies. Less sunlight reflecting. The oranges and reds, more sunlight reflecting, inactive phase. And let's get ourselves oriented here. The equator right there. date line right there. South America, Central America, Hawaii, New Guinea there. So it looks like the active phase of the MJO today is over the date line, and the inactive phase is over the maritime continent, starting to push into the Pacific. 5 days from now, inactive phase of the MJO, pretty much in control of the all-important Kelvin wave generation area, building to strong 10 days from now and holding strong 15 days from now. This is a statistic model. So basically, our swell production window ends somewhere in the next couple of days, and then we go into this inactive phase pattern according to this model. But again, that's not necessarily bad relative to California. It'll cause the jet to strip to split, and create backdoor troughs pushing into California with luck. All right, the GEFS model, the GFS dynamic model, suggests the same thing, but with the inactive phase far weaker. I suspect this is a little bit underrepresented. You can see the big difference between the statistic model and the dynamic model, the last day of the model run. So we'll see. But again, it's a model going out 2 weeks, how much you want to believe it. Next up, phase diagrams. These are for the same two models. This is a drill down for both the models, statistic model and the dynamic model. This shows you the MJO rotating around the planet, active phase from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. Okay, so this shows the actual active phase is already under the United States, if not in the Atlantic, but that's the core of it. The wind thing sort of lags behind, the same thing with the precip. The further the dot is away from this circle, the stronger it is. So a modest active phase over the Atlantic. The dynamic model suggests the same thing. Oh, and the forecast tracks 1, 2, 3. All of them have the active phase somewhere in the Indian Ocean 2 weeks from now, varying from very weak to really strong. The GEFS model has it pretty weak over the East Indian Ocean, maybe the far west maritime continent. So you see there is a considerable difference between just two models, and if you have 3 or 4, well, then you'll get even more of a spread. The upper level model, this is a statistic model showing areas favorable for precipitation. The oranges are dry air, the greens, wet air. Green would be active phase, red inactive phase. And let's get this goes out 40 days, 5 days a panel. South America, Central America, New Guinea there, the equator there. Dateline roughly here. You can see it at inactive phase of the MJ over the maritime continent 5 days from now, moving into the Pacific. You can see it just making its whole trek across the Pacific for the next 40 days. But its strongest influence over the Pacific goes to about April 8th. And then as we get to the 13th, the active phase starts building over the maritime continent and makes its foray into the West Pacific. So we'll say really reasonably about the 18th of April into the beginning part of May. But what happens, this is at upper levels, so, 20, 30,000 feet. What happens at the surface lags behind for about 4 or 5 days. So we would say at a minimum, mid-April into mid-May or early May is probably the next hope for the active phase of the MJO. By then, winter should be pretty much winding down. Don't know how much of an influence it's really going to have on storm production. That said, with El Nino in play and any active phase, they do tend to amplify each other. They constructively interfere with each other. And if you're going to get any sort of a squeeze out of it, this is going to be it. And one more model going out 30 days, the CFS model. So let's see, the dateline runs right down the middle. Far West Pacific starts at 125 east, so right there. And the end of the Kelvin wave generation area right in here. All right, here's where we are today. The solid contour, the black lines, are the active phase of the MJO. So you can see dotted contour back in December and January, inactive phase with the blues, easterly anomalies. Then came our active phase in the latter part of January and February with westerly anomalies. Our next inactive phase happened in February with easterly anomalies. Here we are in our current active phase, and it's all but pretty much wound down here. This shows some lingering remnant westerly anomalies holding for maybe 3 or 4 more days, and that's it. Then the dotted contour and blues are inactive phase of the MJO, setting up, traversing the Kelvin wave generation area into about April 10th or something like that. But even after that, easterly anomalies persisting and no sign of the active phase of the MJO. Now we move to the ENSO part of the discussion, the El Nino Southern Oscillation, the long-term oscillation, maybe a year or so in the El Nino state, and then sometimes 2 or 3 years in the La Nina state, followed by some neutral pattern in between. All right, so what we're looking at now is subsurface temperature, actual temperatures, data from the TAO buoy array. This is the East Pacific here, West Pacific here. These little X's here, these are sensors on the anchor lines of the buoys. They are used in conjunction with the model to fill in the gaps to get a profile of where the warm and cold subsurface temperature water is. Why do we care? Well, during El Nino, you get westerly anomalies in the West Pacific. That takes warm water that's here, starts pushing it to the east, and eventually, like this past El Nino, we had 8 or 9 Kelvin waves. That is bursts of westerly winds in the West Pacific that took this warm water, pushed it to the east in a ball known as a Kelvin wave that eventually impacted the Galapagos Islands and Ecuador, erupted to the surface, and then changed the balance of warm water from normally being in the West Pacific to being in the East Pacific. That in turn changes the whole jet stream flow and ushers in the classic El Nino pattern. But now we're looking at the sea surface temperature profile. There are no longer 30 degrees centigrade. Those are pretty warm water temperatures in the West Pacific. The 29-degree isotherm holding about where it was last week. The 28-degree isotherm holding about like where it was last week. The 24-degree isotherm holding about where it was last week. But what we do notice is, so at the peak of El Nino, the 24-degree isotherm was really almost 60 meters deep. Now it's 21 or 22. So the warm water pool is getting significantly thinner here, while the warm water pool in the west is getting thicker. In fact, we can see that transition here in the anomalies, the difference from normal for this time of year. And you see a thin little bit of what is only 1 degree above normal anomalies here. The last remaining bits of El Nino slowly getting caught by the trades and dragged off to the west. And instead of Kelvin waves and warm water pushing west to east on the thermocline, we have cold water, 1, 2, 3, 4, almost 5 degrees below normal here in a giant pool, all this moving off to the east. It will eventually start erupting here, poking its way because it's got momentum behind it, poking up, erupting along Ecuador and actually Peru, driven by the trades here and a bunch of other things. And the ocean will return to its normal, more neutral, at least its more neutral self, with cold water in the east and warmer water in the west. Another version of that chart using a mixture of satellite data and the buoys, painting the same picture. Yeah, a little bit of warm water hanging off of Ecuador, but mainly cold water erupting to the surface, being dragged, pushing the trades, pushing this warm water off to the west, and you end up with upwelling and this tapping this cool pool, driving up to the surface, and the end of El Nino. Pentad sea level anomalies, this is not temperatures, this is the height of the ocean. Is the ocean higher or lower than normal? If it's higher than normal, that's an indicator of warm water at depth. Warm water expands. When it does, it displaces the water above it, creates a bump on the ocean surface. Cold water at depth contracts, does the same thing, or the inverse, creates a divot on the ocean surface. So Chile, Peru, Ecuador, the Galapagos right there, this is the equator. date line right there, we see negative anomalies, all indicative of colder than normal water now over the entire equatorial Pacific. 3 months ago, this was all cooking warm, positive anomalies, warmer than normal temperatures. Now we're moving at least subsurface towards La Nina. That doesn't mean, though, that we are in La Nina yet. The foundation, the underpinnings of La Nina are developing now. Upper ocean heat anomalies tells the same picture. You can see this is time, West Pacific here, East Pacific here, back in March of 2023. Kelvin wave, warm water traversing across the Pacific, driven by the active phase of the MJO. You wonder why I harp so much on the MJO, because not only does it feed the storm track and feed the jet stream, it also feeds the development of El Nino or La Nina, and so it is a significant global weather enhancer or unenhancer, depending on how you want to look at it. But anyway, more Kelvin waves, and then the last little piece of a Kelvin wave, January of this year, made it across the Pacific in February, and then here is our building cool pool, the beginnings of La Nina. So you see all that, you think it's doom and gloom, you think that, we're just falling down a hole deeply into La Nina, and we maybe are, but we're not there yet. Looking at sea surface temperature anomalies and the all-important area from Ecuador and the Galapagos right in here all the way out to the dateline and beyond, the oranges and reds are warmer than normal temperatures. All we have is this, it looks like 2 pockets, but it's really the same pocket. So 2 pockets of cool anomalies trying to work their way to the surface. The first little tip of that cold water Kelvin wave erupting here off the coast, but the remnants of El Nino still clearly in control, still affecting the atmosphere above it, still constructively interfering with the active phase of the MJO, and doing good things in terms of precipitation for California. And again, this is not going to dissipate overnight. It took months for this to build. It will take months for it to dissipate. And then on top of that, the jet stream is like an even bigger boat. It takes a year for it to change direction from one way to the next. And it just peaked out in its El Nino configuration the end of January. So it's going to be at least till December of this year before this, if it turns all cold and turns into La Nina, before it completely rips the momentum out of the jet stream. So for now, we're doing pretty good. The sea surface trend for the past 7 days, South America, Central America, equator right here. Blues, cooling temperatures, actually not as bad as even last week or the week before. And then a significant warming trend out in this area. But why is it warming? Well, what's really happening is trades and the upwelling are taking whatever's left of the warm water that was here, pushing it off this way. It's acting like a bulldozer and scraping it across the Pacific. And what happens is the last of the warm water actually sort of builds up in front of the bulldozer. But I think over time you'll see the trailing edge of this working itself more and more off to the west as the cold water pattern starts erupting to the surface. And then the backed off view, again, you see lots of warmth, El Nino pattern still in play, and you don't even want to look over in the Atlantic how much warmer than normal the temperatures are here. With a building La Nina pattern, one would expect that with these higher than normal surface temperatures and enhancing evaporation as we get into the July, August, September timeframe in the Atlantic, this will do a lot for feeding hurricanes. And with the El Nino fueled shear that typically runs across this area, transitioning to La Nina, the momentum or the shear will decrease, theoretically, possibly supporting hurricane development. Also of note, during El Nino years, the summer after an El Nino winter, the southern hemisphere normally does pretty good, right under New Zealand. Again, the momentum in the jet stream, the pattern that we've all been talking about, it theoretically should feed gale development down in this region. That said, we had seen some troubling signs with the Southern Oscillation Index. We'll get into that in a minute, but basically that maybe high pressure was stronger over the at least the equatorial Pacific than normal for this El Nino, and so the southern oscillations didn't drop, and the index didn't go as negative as one would expect. So that could be a mitigating factor, and this El Nino has been weird too. And so I'm still thinking we'll have a normal southern hemisphere pattern during our northern hemisphere summer in terms of storms and swell, and maybe a little bit more, but it could be a little bit less too. A little too complex to know for sure. Sea surface temperature trend for the Nino 1.2 region. This is the area right there by Ecuador and the Galapagos. Temperatures trending downward. Neutral is at 0 degrees. We're at 67 thousandths of a degree below normal, so basically dead neutral. And you see we were up at 1, and we were up at +3 at one point during the peak of El Nino. So a downward trend here. The official El Nino monitoring region, this is on the equator from south of California out to about the dateline, slowly trending downwards, but still plus 1.12 degrees above normal, and that's the CDAS number is down by about 0.2 of a degree. So this is, well, that is the beginning of weak El Nino. That's the beginning of moderate El Nino. That's the beginning of strong El Nino. So still solidly in the moderate El Nino category. Momentum still there to support the jet stream. And one more chart just showing the buildup of sea surface temperatures back. So this is the East Pacific. This is the West Pacific here. This is back in March of last year. The building of warm water temperatures, but the thing now to see is the cooling of those temperatures and the extent of that cooling starting to creep its way across the equatorial Pacific. And then next up, the Southern Oscillation Index. This is just gives us an indication of what effect is all this having on the atmosphere. The ocean subsurface temperatures can do their thing that eventually work their way up to the surface, and that does its thing. And then it is once the temperatures start changing on the surface that affects the atmosphere above it. We know that the surface temperatures aren't changing that much. So we look at this difference in pressure between Darwin, Australia and the Indian Ocean and Tahiti in the Pacific Ocean. If pressure is lower in Tahiti, the index goes negative. Well, today it's minus 0.43, so basically dead neutral. And where has it been? It's been neutral to slightly positive for a month now, really not doing anything. And this goes back to what we were talking about earlier. There's we think some high pressure anomaly that's been in play over the equatorial Pacific and maybe the South Pacific that kind of dampened this index and maybe even dampened El Nino and maybe had something to do with the PDO. We'll get into that discussion at another time. Anyway, this should have been far lower, like down at minus 20 or 25 for weeks on end at the peak of El Nino. It never got close. 30-day average today at plus 2.69. That's basically neutral and has been, well, you see it was down at 18 there, and that should have been down around 25. The 90-day average, minus 2.98, and I don't know that it got much below minus 0.5, and it should have been down at minus 10 or 15 for quite a long time if this was a real El Nino. We think, again, that is because Tahiti had more high pressure than normal during the entire length of this El Nino. Here's the 30-day moving SOI graphed out, neutral right here. This was during our La Nina thing in 22. Then as we got into 23, you just see, boom, this is active phase after active phase after active phase, and we're down at minus 20, and we go, we're in business here. And then all of a sudden, it went basically neutral. It dropped back down, but never got really down. And in the fall, when this thing should have been down around 20 or even 25, it was going inactive phase, going up. Yeah, we got another little drop, but again, we think this might be associated with that high pressure anomaly in the South Pacific. Sea surface temperature forecast for the official El Nino region, the Nino 3.4 region, from the CFS version 2 model. There was our peak of El Nino back in December, 2 degrees above normal, and then slowly, steadily fading. Today at plus 1.3 degrees roughly, but forecast, I think this model is grossly overstating the quickness of the transition, suggesting it falling to minus 2 degrees. The other version of the model, the PDF corrected, has it at minus 1.55, the fall of this coming year, but we have the consensus model. And this is a view of every known El Nino model, all the dynamic models here, all the statistic models here. There is neutral there. Okay, and these are 3-month periods, so April, May, June, July, you get it. You get into September, October, November. So we'll see if we can just pick off. The statistic average has it at -1. The dynamic average right here has it at about 0.98, just eyeballing it. The consensus of those two has it at -0.7. That is barely, the threshold for La Nina is 0.5 degree. 0.7, I'll take that any day of the week and run with it, especially after a quote-unquote strong El Nino. Even if it's just 0.75 or 0.8 below normal, that would not be too bad. Let's go look at the actual data. So here's all the models here. We're going to start by looking at the dynamic models here. And here, 3 months at a time, here's what their averages are. I'm not even going to go pick each of the individual models. But what we will do is go look at the average of the dynamic models. It shows temperatures down to -1.097 in September, October, November, and then hanging around 0.9. The statistic models right here, their whole deal, they have -1.011, so both models at about -1. And in the September, October, so October would be the center of that period, and then settling out at about -0.9, let's say, or -0.95. If that's what really happens, that would be pretty much epic. Now, the catch on all this is, there's a thing called the spring unpredictability barrier. It's just the models have a really hard time during spring because the seasons are changing and they can't really get a handle on anything. The spring predictability barrier starts somewhere around now and runs till about the end of May. So, the end of May. So by June, I think we'll have a much better handle on what things are. But I mean, if we come out anywhere in the -1 degree range, that is not too strong of a La Nina, and I'll take it. Okay, so for right now, surf-wise, well, there is swell, but at least relative to California, there's also a bunch of weather associated with it. It's going to be quite a trick to go get clean waves somewhere, but if you know the right nooks and crannies in the coast, you will get surf. I would say at this point, I'm really speaking for myself, I need to sort of lower my sights now, and it's time to start groveling, because as we get further into spring, what's really going to be interesting to see if we get the nuking northwest wind events that you typically get, at least during a La Nina springtime. During El Nino, typically that doesn't happen, and yeah, you get the northwest winds, but it also sort of calms down at times too. So we'll see how things play out, but we're definitely starting to move into springtime mode, and it is time to grovel, and that's just the way it is. The good news is, though, inactive phase of the MJO, split jet stream, at least for California, that does great for the backdoor trough scenario and maybe more precipitation. Precip-wise, looking across the state, Southern California is like at 130% of normal precip. Central California is 110, I think. North California, San Francisco Bay Area is like at 90%. Then further up north, they're back at 100 or 110%. So we're doing okay. Give us more rain, though, and especially give us more snow in the mountains. That is our insurance policy for the summer. So last year was great in terms of precip. The reservoirs are all full. This year will be good. We're also looking towards next year, because typically the winter after an El Nino, again, that momentum that we talked about, it's still in the atmosphere. It's still lots of moisture. And from the Tonga volcano, that they're talking 3 or 4 years worth of precip or moisture ejected up into the atmosphere. So that plays a part in all this too. And so next year could be a good snow year. But then with the coming La Nina, as you just saw in the models, even if it's not too strong, odds are we're going to go into a deficit for rainfall for California. And so we need this year and hopefully next year. That'll give us 3 years of padding. Then we should be in good shape to handle a couple of years of drought. The typical cycle for California. For Hawaii, surf-wise, yeah, not so good. I mean, the jet stream is just peeling apart and then storm tracks falling apart. Get what you can, make the most of it. And beyond that, yes, we know some flavor of La Nina is coming, but hopefully it won't be too bad. For the moment, the models are cautiously optimistic. And with that, that's the end of this week's forecast. If you enjoyed it, give us a thumbs up. If you have any comments or question, write them down below. We'll be happy to answer, or some of the other folks, the other viewers, I'm sure will apply as well. And if you haven't subscribed, subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you'd like to make a contribution, hit the special thanks button down below. And with that, we are done for this week, but we will do it again next week, same time, same channel. Thanks for watching.